Simulan mong abutin ang iyong pangarap na magbibigay dangal sa iyong bukas. Ang suliranin, hindi laging nandyan, dapat mong harapin. Kami iyong kasama sa bawat takin, magkaakbay nating lulutasin. Dito sa FerNanDino Teens TV, ang boses mo ay mahalaga. Dito sa FerNanDino Teens TV, ikaw lagi ang bida. Ang mga aral ay ginintuang atin ng bawat guro na siyang gagabay sa iyong pagkamulat. Naway umukit ito sa iyong isipan, maging mapanuri, sundin ng wasto at nararapat. Kagandahang asal ang ipakita, ipadama ang pusong may malasakit. Dito sa FerNanDino Teens TV, ang boses mo ay mahalaga. Dito sa FerNanDino Teens TV, ikaw lagi ang bida. Sakali mang tayo'y supo ng unos, ating haharapin ng walang takot. Sasamahan ka ni Fernan at Dino, ang bagong barkada mo. Dito sa FerNanDino Teens TV, boses mo ay mahalaga. Dito sa FerNanDino Teens TV, edukasyon mo'y sigurado na. Dito sa FerNanDino Teens TV, boses mo ay mahalaga. Dito sa FerNanDino Teens TV, edukasyon mo'y sigurado na.
FerNanDino Teens TV.
Ano yung pinagkakaabalahan mo? Okay ka lang ba?
Binabasa ko kasi tong week 1 module ko sa basic calculus tungkol sa limits. Hindi ko maintindihan. Hay, nasa na ba si Dino? Sabi niya tuturuan niya ako eh.
Mamaya na natin hanapin si Dino. Manood na muna tayo ng episode ngayong araw. Balita ko, tungkol dyan ang magiging talakayan.
Talaga ba? Buti naman. Ang laking tulong talaga ng FerNanDino Teens TV. Tara,
Let's watch and learn!
The capacity to learn is a gift. The ability to learn is a skill. The willingness to learn is a choice. A notable quote by Brian Herbert. Good morning. Welcome to another learning episode here in FerNanDino Teens TV. I am Sir Harley, your teacher on screen for today. How are you, FerNanDino teens? I hope you are all doing good and are safe at home while studying and answering your self-learning modules. Let me start this learning session by asking you this question. Are you familiar with calculus? Some of you might say that this subject is only intended for STEM or engineering students. Maybe you perceive it as a challenging subject. Well, we can never eradicate such stereotyping, and I am not here to persuade and make you believe that this topic or subject is easy. But at least, give me the chance to share with you the basics of calculus through a walkthrough. Join me in today's exciting and fun-filled episode titled Limits, Learning the Foundation of Calculus. Are you excited? Let's get started. To begin with, may I present to you the learning objectives of this episode. First, Illustrate the limit of a function using a table of values and the graph of the function. Second, illustrate the limit laws. And third, apply the limit laws in evaluating the limit of algebraic functions. Before we proceed to the discussion of limits, let us have a review in form of a game titled Guess That Polynomial that will test your knowledge on the different types of polynomial functions that you will encounter throughout this episode. Determine whether the given polynomial function is a constant, linear, or a quadratic function. You may answer orally, comment your answer on the comment box, or write your answer on a sheet of paper. Write C if it is a constant function, L if it is linear function, or Q if it is quadratic function. You will be given 5 seconds to answer each item. Are you ready? First, f of x is equal to 3x plus 2. Next, f of x is equal to 3. Lastly, f of x is equal to x squared minus 4. If your answers are L, C, and Q, you are correct. Very good! In this learning episode, we will also discuss rational and piecewise functions. Rational function is the ratio of two polynomials. In symbols, f of x is equal to n of x over d of x, where d of x is not equal to 0. Here are some examples of rational functions. F of x is 1 over x, where x cannot be equal to 0. And g of x is x all over x squared minus 9, where x cannot be equal to positive and negative 3. While a piecewise function is defined by two or more functions over a specified domain. Here is an example of a piecewise function. F of x is x plus 1 if x is less than 1, and negative x plus 2 if x is greater than or equal to 1, wherein the given conditions are the domain of the function. Limits are the backbone of calculus, and calculus is called the mathematics of change. The study of limits is necessary in studying change in detail. The evaluation of a limit is where the formation of the derivative and the integral of a function underlies, or in layman's term, the differential and integral calculus. At this point, I want you to think of your favorite sports team, which games you want to watch live. How about your favorite band or artist that you eagerly want to watch perform live in a concert? For starters in calculus, imagine yourself in either of these two situations. You are going to watch a basketball game or any sports event, or you are going to watch a concert of your favorite band or artist. When you choose seats, you would want to be as close as possible to the action. You would want to be near the players or artists as much as possible and have the best view of the game or the concert, as if you were in the basketball court or on the stage yourself. Take note that you cannot be in the court and join the players or join the artists on the stage, but you will be close enough to describe clearly what is happening in the game or concert. This is how it is with limits of functions. We will consider function f of a single variable and study the behavior of the function as its variable approaches a value which is a constant c. The variable can only take values so very close to the constant, but it cannot be equal to the constant itself. However, the limit will be able to describe clearly what is happening to the function near that constant. Now, consider a function f of a single variable x. Consider a constant c which the variable x will approach. C may or may not be in the domain of the function f. The limit, to be denoted by L, is the unique real value that f of x will approach as x approaches c. In symbols, we write this process as like this. This is read as the limit of f of x as x approaches c is L. There are three ways on how to determine the limit of a function. These are looking at the table of values, looking at the graph, and evaluating through limit laws. Before we begin the discussion in determining the limits of a function by looking at the table of values, let us have a game first. help Fer and Nan to meet within the vicinity of Pampanga High School. This is the scenario. Fer and Nan are going to Pampanga High School for the first time. Fer entered through the front gate, while Nan entered through the back gate. Consider now this illustration and the path that they are traveling. Based on the scenario, can you determine where they are heading? Amazing! Fer and Nan are approaching and will be meeting at the Dama de Noche building. You want more? Do not worry, we will have more activities later. Just sit back, relax, and enjoy, for when we return, we will determine the limits of a function by looking at its table of values. Ready your scientific calculator, paper, and ballpen, for we will be using those in the next part of the discussion. Do not change your channel.
Maya pa oras kaya kayo, FerNanDinos. Ako pala ay Elwin Arl Serrano ng City Tourism Office ng Siyudad San Fernando. Ngayong bulan na ini, pagmasusyantaya ang National Heritage Month, na ating temang Victory and Humanity, Upholding Filipino Heritage and Identity. Kambena nini, metong karang aktibidades na ng siyudad, apin ng launching ng bayong Heritage Passport. Yung Heritage Passport, apin ng metong karing proyekto ng kakatamong siyudad, yung pamanamuna ng Mayor Edwin D. Santiago. Anong nuka rin makalagelangan ding eganagan ng heritage sites, heritage structures, naakit tamo kin kay katamong heritage district. Makakayado din kini, ding importansya da ding mapil na tradisyon kay ni syudad, kalupa na ning pamangawang parol, ang po yung pamangalesa. May awo siyang heritage passport, uling atin kang dapat gawan, anong nukaran puntalan mo lading at yung passport, at saka ka mag-selfie. Kay ba't kanta, palto making tourism office, at mamiyalang sticker ka rin eganaganang apuntulan mong lugar. At timaw may ngari ang tutong passport. Balo mi ngeni, panahon na ini, etamo makain bisa lumal, uli na ng COVID-19 pandemic. Kaya naman kimbanwa nga ini, agkatan ko la ding bikers tamo, edad 18 hanggang 50, imbis na lumaot kayo po, di na nyo lang dita ka oras di kaya katamong heritage structures, kaya ni syudad. Anya naman karing mumunang 50 bikers ang makayari kaya katamong heritage passport, midinan lang premyong only San Fernando loot bag. Inggawan nyo mo bakanta makapag-register, munta kayo mismo opisina na ng City Tourism, ng munisipyo, at saka kayo magdalang metong valid ID. Kabinan ng kaya kayong heritage passport, ating makasipit ang instruction nung nano pa ing dapat gawan. Anya naman ka rin hanggang kapadyakin, nanano ko pa, tara na!
FerNanDino Teens TV.
You're still watching FerNanDino Teens TV. Before the break, we discussed that limits are the backbone of calculus, and calculus is called the mathematics of change. Limit, to be denoted by L, is the unique real value that f of x will approach as x approaches c. And there are three ways on how to determine the limit of a function. These are looking at the table of values, looking at the graph, and evaluating through limit laws. First, let us now discuss on how to determine limits by looking at the table of values. A table of values is a graphic organizer that is used to determine two or more points that can be used to draw the graph of a certain function. To illustrate, let us consider the following examples. Example number 1. The limit of 1 plus 3x as x approaches 2. Here, f of x is equal to 1 plus 3x, a linear function, and the constant c, which x will approach, is 2. To evaluate the given limit, we will make use of a table to help us keep track of the effect that the approach of x towards 2 will have on f of x. Of course, on the line, x may approach 2 in two ways, from its left or through values on its right. We first consider approaching 2 from its left or through values less than 2. Remember that the values to be chosen should be close to 2. Substitute the given values of x to the function. Solve for the value of the function and complete the given table. Now, get your calculator and we will start solving f of x using the given x values. Since f of x is 1 plus 3x, replace x by the given x values. If x is 1, f of x is 1 plus 3 times 1 will result to 4. If x is 1.4, f of x is 1 plus 3 times 1.4 will result to 5.2. If x is 1.7, f of x is 1 plus 3 times 1.7 will result to 6.1. If x is 1.9, f of x is 1 plus 3 times 1.9 will result to 6.7. Doing the same procedure all over again, we will obtain the following f of x values. Now, we consider approaching 2 from its right or true values greater than but close to 2. If x is 3, f of x is 1 plus 3 times 3 will result to 10. If x is 2.5, f of x is 1 plus 3 times 2.5 will result to 8.5. If x is 2.2, f of x is 1 plus 3 times 2.2 will result to 7.6. If x is 2.1, f of x is 1 plus 3 times 2.1 will result to 7.3. Doing the same procedure all over again, we will obtain the following f of x values. Observe that as the values of x get closer and closer to 2, both left and right of 2, the values of f of x get closer and closer to 7. This behavior can be shown no matter what set of values or what direction is taken in approaching 2, the value of the function is approaching 7. Therefore, the limit of 1 plus 3x as x approaches 2 is 7. In symbols, we can write it in this format. Example number 2. The limit of x squared plus 1 as x approaches negative 1. By constructing table of values for the given, here c is negative 1 and f of x is x squared plus 1, a quadratic function. We start again by approaching negative 1 from the left. If x is negative 1.5, f of x is negative 1.5 squared plus 1 equals 3.25. If x is negative 1.2, f of x is negative 1.2 squared plus 1 equals 2.44. Doing the same procedure all over again, we will obtain the following f of x values. Now, approach negative 1 from the right. If x is negative 0.5, f of x is negative 0.5 squared plus 1 equals 1.25. If x is negative 0.8, f of x is negative 0.8 squared plus 1 equals 1.64. Doing the same procedure all over again, we will obtain the following f of x values. The tables show that as x approaches negative 1, f of x approaches 2. Therefore, the limit of the function as x approaches negative 1 is 2. In symbols, we can write it in this format. Example number 3. The limit of x squared minus 5x plus 4 all over x minus 1 as x approaches 1. By constructing tables of values for the given, here, c is 1 and f of x is x squared minus 5x plus 4 all over x minus 1, a rational function. Take note that 1 is not in the domain of f, since upon evaluation, 1 will make the function undefined. But this is not a problem. In evaluating a limit, remember that we only need to go very close to 1. We will not go to 1 itself. We now approach 1 from the left. If x is 0.5, f of x is 0.5 squared minus 5 times 0.5 plus 4 all over 0.5 minus 1 will yield negative 3.5. If x is 0.88, f of x is 0.88 squared minus 5 times 0.88 plus 4 all over 0.88 minus 1 will yield negative 3.12. Doing the same procedure all over again, we will obtain the following f of x values. Let us now approach 1 from the right. If x is 1.5, f of x is 1.5 squared minus 5 times 1.5 plus 4 all over 1.5 minus 1 will yield negative 2.5. If x is 1.12, f of x is 1.12 squared minus 5 times 1.12 plus 4 all over 1.12 minus 1 will yield negative 2.88. Doing the same procedure all over again, we will obtain the following f of x values. The table shows that as x approaches 1, f of x approaches negative 3. Therefore, the limit of the function as x approaches 1 is negative 3. In symbols, we can write it in this format. Example number 4. The limit of f of x as x approaches 4, where f of x is x plus 1 if x is less than 4, and the quantity x minus 4 squared plus 3 if x is greater than or equal to 4. This time, the given is a piecewise function. This looks a bit different, but the logic and procedure are the same. We still approach the constant 4 from the left and from the right, but note that we should evaluate the appropriate corresponding functional expression. In this case, when x approaches 4 from the left, the values taken should be substituted to f of x equals x plus 1, satisfying the condition that x should be less than 4. Indeed, this is the part of the function which accepts values less than 4. Here, calculator is not needed. Just add 1 on the given x values and we can obtain the f of x values 4.7, 4.85, 4.995, and 4.99999. On the other hand, when x approaches 4 from the right, the values taken should be substituted to f of x equals quantity x minus 4 squared plus 3. If x is 4.3, f of x is quantity 4.3 minus 4 squared plus 3 is equal to 3.09. If x is 4.1, f of x is quantity 4.1 minus 4 squared plus 3 is equal to 3.01. Doing the same procedure all over again, we will obtain the following f of x values. Observe that the values that f of x approaches are not equal. F of x approaches 5 from the left, while it approaches 3 from the right. In such a case, we say that the limit of the function does not exist. In symbols, we can write it in this format. It is important to note the following. We do not say that the limit of f of x as x approaches 4 equals d and e, nor do we write the limit of f of x as x approaches 4 is equal to d and e, because d and e is not a value. In the previous example, d and e indicated that the function moves in different directions as its variable approaches c from the left and from the right. In other cases, the limit fails to exist because it is undefined, such as for the limit of 1 over x as x approaches 0, which leads to the division of 1 by 0. Have you noticed a pattern in the way we have been investigating a limit? We have been specifying whether x will approach a value c from the left or from the right. This direction may be specified in the limit notation, limit of f of x as x approaches c by adding certain symbols. If x approaches c from the left, then we can write it in this format. If x approaches c from the right, then we write it in this symbol. These expressions are read as the limit of f of x as x approaches c to the right or to the left. Take note that the positive and negative signs there are not exponents, but a symbol for direction. Furthermore, we say the limit of f of x as x approaches c is equal to L if and only if the limit of f of x as x approaches c to the left is equal to L, and the limit of f of x as x approaches c to the right is equal to L. In other words, for a limit to exist, the limits from the left and from the right must both exist and be equal to L. Therefore, the limit of f of x as x approaches c does not exist whenever the limit of f of x as x approaches c to the left is not equal to the limit of f of x as x approaches c to the right. There you have it, FerNanDino teens. When we return, we will discuss the two remaining methods in determining limits of functions. We will be right back after a short break.
Magtanim ay di biro, pero para sa retired teacher na si Mang Tomas Gamboa, isa itong pangarap na matagal na niyang inaasam na anihin. Kaya naman sa 500 square meter lot na ito sa Florida Blanca, Pampanga, unti-unti niyang tinamnan at pinalago ang naipong kita sa mahigit 20 taon niyang pagtuturo. Kaya, tara na't pasukin ang paraiso ng ating bidang guro.
Welcome to Mape Garden Farm. Tara!
Mula sa makukulay na disenyo hanggang sa iba't ibang klase ng planting methods, makikita yan sa personal gulayan na tinawag nilang Modern Agriculture Farm Edition. Talaga namang binuhos ni Mang Tomas ang kanyang expertise sa pagtatanim at syempre, hindi mawawala ang pagiging resourceful ng ating resident planter.
Yung paggamit ng mga materials sa pagtatanim, iba-iba. May plastic, may gulong, may sako, may bote, lahat ng klaseng bote na pwedeng gamitan. Ginamit ko na.
Experimental ang approach ni Mang Tomas, pero pagdating sa soil mixing, organic ang swak na soil mixture na approve sa ating green thumb. Pinaghahalo lang ang soil, topsoil, ipa, at carabao manure para sa optimum growth ng mga healthy veggies. Halos lahat pa ng mga gulay sa kantang bahay kubo present din dito sa kanyang lupain. Kaya naman ang buong pamilya ni Mang Tomas hanggang sa mga apo niya enjoy sa pag-harvest at pag-aalaga ng Mafe Garden Farm na ipinangalan niya pa sa kanyang mga anak.
Na kayo, siyempre, di ba, mahilig kayo magluto?
Oo.
Ano pong naging ambag nito?
Mula nung tinahi ito, natuto kami lagi mamasyal dito, lagi nagluluto, dala-dala lahat yung mga pagkain. Dito kami nagpipiknik.
At itong mape na sinasabi, ito'y pag-aari ng dalawa kong anak. Binibigay ko sa kanila. Regalo. Ako ang magiging caretaker nila. Yung mape,
Ang kalinga ng isang ama, ramdam hindi lang sa pamilya, kundi sa mga pananim niya. Kaya naman ngayong pandemya, make yourself busy, bawasan ang stress, at mas maging productive sa tulong ng pagtatanim para may dagdag hain na rin. Kaya para sa mga plantitos at plantitas na gustong i-level up ang planting skills,
papayo ko sa mga kasama kong retirees, lalo sa mga teachers na hindi major ng agriculture, pwede kayong kumuha ng background sa Facebook. Pangalawa, kung konti lang yung pera nyo na ipon, pwede kayong kumuha ng 200 to 300 square meter at pakonti-konti, pwede kayong magtanim na kinakailangan ng pang-araw-araw na gamitan sa kusina at makakalibang pa sa pansarili mo.
para sa Balita Pampanga, Gerald Gloton. FerNanDino Teens TV.
Welcome back to FerNanDino Teens TV. Before the break, we discussed how to determine limits of functions by looking at the table of values. At this juncture, let us discuss the second method on how to determine limits, which is by looking at the graphs of functions. If one knows the graph of f of x, it will be easier to determine its limits as x approaches given values of c. First example, consider again f of x is 1 plus 3x. Its graph is a straight line. Look at the graph in the vicinity of x equals 2. On the left, you can easily see the points 1 and 4, 1.4 and 5.2, 1.7 and 6.1, and so on, approaching the level where y is 7. The same can be seen from the right, by just simply looking at the point that contains c, which is 2 in this case. The y-coordinate of that point, which is 7, is the limit. Most of the time, this method is used. Hence, the graph clearly confirms that the limit of 1 plus 3x as x approaches 2 is 7. Second example. It can be seen from the graph that as values of x approaches -1 from left and right, the values of f of x approaching the level where y is 2. Also, by looking at the point that contains c and getting the y-coordinate of that point, it can be confirmed that the limit of the given function is 2. Third example. It can be seen from the graph that as values of x approaches 1 from the left and right, the values of f of x approaches the level where y is -3. Here, it does not matter that f of 1 does not exist. That is, it is undefined, or x equals 1 is not in the domain of the function. Always remember that what matters is the behavior of the function close to c equals 1, and not precisely at c equals 1. In fact, even if f of 1 was defined and equal to any other constant like 100 or 5000, this would still have no bearing on the limit. In cases like this, the limit of the function's -3 prevails regardless of the value of f of 1, if any. Fourth example. Again, we can see in the graph that f of x has no limit as x approaches 4. The two separate parts of the function move toward different y levels. Y equals 5 from the left, and y equals 3 from the right in the vicinity of c equals 4. In general, if we have the graph of a function, determining limits can be done much faster and easier by inspection. Consider the limit that the function will approach. It will serve as the x-coordinate of the point that we are looking for to determine the limit. First, locate the x-coordinate, which is c, on the coordinate plane. Then, determine its pair, the y-coordinate, which is to be the limit of the given function. If there are multiple points within the vicinity of the given c value, then the limit of the given function, like in the case of the fourth example, does not exist. What if there are numerous graphs within the Cartesian plane? Let us have the last example. Let us determine the following using the given graph. First, what is the limit of f of x as x approaches -3? Looking at the vicinity of the point that contains x equals -3, the y value of that point is 1. Also, looking at the left and the right of x equals -3, the trend of the graph approaching on the level where y is located is 1. Thus, the limit of the function is 1. Second, what is the limit of f of x as x approaches -1? Since there are more than one point on the vicinity where x is -1, therefore, the limit of f of x as x approaches -1 does not exist. Third, what is the limit of f of x as x approaches 1? Looking at the vicinity of the point that contains x is 1, the y value of that point is -2. Also, looking at the left and right of x equals 1, the trend of the graph approaching on the level where y is located is -2. Thus, the limit of the function is -2. Fourth, what is the limit of f of x as x approaches 3? Since there are more than one point on the vicinity where x is -1, therefore, the limit of f of x as x approaches 3 does not exist. There you have it, FerNanDino teens. We are now down to the last method in determining limits of function, which is through evaluating using limit laws or limit theorems. At this point, we will illustrate the 8 limit laws. First on the list is the limit of a constant is itself. If k is any constant, then the limit of k as x approaches c is k. Here, if the given function is a constant function, automatically, that constant will be the limit. Examples. The limit of 2 as x approaches 6 is 2. Next is the limit of 5,000 as x approaches -12 is 5,000. Lastly, the limit of the natural number e as x approaches 9 is the natural number e. Next, the second limit law. It states that the limit of f of x as x approaches c is equal to c. It is also known as substitution law. In symbols, in this theorem, the limit of the function is the c value that it will approach, or simply replace x by the c value. Examples: the limit of x as x approaches 9 is 9. Next, the limit of x as x approaches 0.005 is 0.005. Lastly, the limit of x as x approaches negative 10 is negative 10. Third is the constant multiple theorem. It states that the limit of a constant c times a function is equal to the constant c times the limit of the function, provided that the limit of f of x as x approaches c exists. In symbols, here, the numerical coefficient of the function x will be written first. Then, write the limit notation. Applying the second theorem, we can determine L. Lastly, multiply the numerical coefficient and L. Let us apply this scheme to these examples. The limit of 4x as x approaches 2. Write first 4, then it will be multiplied to the limit of x as x approaches 2. Applying substitution law, we will obtain 4 times 2. Getting the product of 4 and 2, it will result to 8. Thus, the limit of 4x as x approaches 2 is 8. Next example, the limit of 16x as x approaches 3. 16 will be multiplied to the limit of x as x approaches 3. Applying the second limit law, the result will be 16 times 3. Multiplying 16 and 3 will yield 48. Thus, the limit of 16x as x approaches 3 is 48. Fourth in the list is the addition theorem. This says that the limit of a sum of functions is the sum of the limits of the individual functions. Subtraction is also included in this law. That is, the limit of a difference of functions is the difference of the limits. Illustrating this theorem, suppose we are to get the sum of the limits of f of x and g of x. We can express it in this manner. Distribute the limit notation to both f of x and g of x. Do not forget to write the limit notation below that x will approach c. In symbols, applying limit laws, we can have the limit of L for f of x and m for g of x. Lastly, get the sum of L and m. This is also applied if the operation is subtraction. Examples: the limit of x plus 7 as x approaches 2. Distributing the limit notation will result to the limit of x as x approaches 2 plus the limit of 7 as x approaches 2. Applying the second and first law on the first and the second term respectively, it will become 2 plus 7. Getting the sum of 2 and 7 is 9. Thus, the limit of x plus 7 as x approaches 2 is 9. The fifth law is the multiplication theorem. This is similar to the addition theorem, with multiplication replacing addition as the operation involved. Thus, the limit of a product of function is equal to the product of their limits. Example: the limit of x times the quantity 5x plus 4 as x approaches 3. Distributing the limit notation, we can obtain the limit of x as x approaches 3 times the limit of 5x plus 4 as x approaches 3. Distributing the limit notation to the terms of the second function and applying the constant multiple theorem on its first term, we will obtain the limit of x as x approaches 3 times the quantity 5 multiplied by the limit of x as x approaches 3 plus the limit of 4 as x approaches 3. Applying the limit laws, we can have 3 times quantity 5 times 3 plus 4. Simplifying the terms inside the bracket, it will result to 3 times 19. 3 times 19 equals 57. Thus, the limit of x times the quantity 5x plus 4 as x approaches 3 is 57. Sixth limit law is the division theorem. This says that the limit of a quotient of a function is equal to the quotient of the limits of the individual functions, provided the denominator limit is not equal to 0. Example, the limit of 2x plus 5 all over x plus 3 as x approaches 2. Distributing the limit notation to all the terms on numerator and denominator and applying the constant multiple theorem on the first term of the numerator, it will become 2 times the limit of x as x approaches 2 plus the limit of 5 as x approaches 2 all over the limit of x as x approaches 2 plus the limit of 3 as x approaches 2. Applying the intended limit laws for each term, it will result to 2 times 2 plus 5 all over 2 plus 3. Simplifying the given, the result will be 9 over 5. Thus, the limit of the function is 9 over 5. Those are the first 6 limit laws. When we return, we will illustrate the 2 remaining limit laws, and we will test your understanding on the things we have discussed in this session. We will be back after a short break. Stay tuned!
Ang Schools Division Office City of San Fernando, Pampanga ay kaisa ng Department of Education sa pagsasagawa ng mga proyekto at programa na tumutugon sa mga pangangailangan ng mga mag-aaral. Inilunsad ang Division Call Center for Tutors and Guidance Counselors upang magbigay ng educational at psychological assistance sa mga mag-aaral, magulang at stakeholders ng Division. Kaya, kung may nais kayong itanong tungkol sa pag-aaral, maaaring magpadala ng mensahe sa Division Call Center for Tutors and Guidance Counselors Facebook page o tumawag sa mga numero na makikita sa ibaba ng inyong screen tuwing Lunes hanggang Biyernes sa ganap na alas 8 ng umaga hanggang alas 6 ng gabi. Maaari rin kayong sumangguni sa ating guidance counselors na nagbibigay ng guidance and counseling services. Lahat ng inyong ibabahagi ay mananatiling confidential. Ang nasabing programa ay nagsisilbi ring daan upang malaman ang feedbacks ng stakeholders para matulungan ang ating divisyon na mapagbuti pa ang mga sumusunod na programa. Ano pang hinihintay ninyo? Tumawag na sa aming mga numero o bumisita na sa aming Facebook page at magpadala ng inyong mga katanungan.
FerNanDino Teens TV.
You are still tuned in to FerNanDino Teens TV. A while back, we discussed the first limit laws, namely, the limit of a constant is itself, substitution law, constant multiple theorem, addition theorem, multiplication theorem, and the division theorem. Let us now resume discussing the 2 remaining limit laws. Seventh on the list is the power theorem. This theorem states that the limit of an integer power p of a function is just that power of the limit of the function. Example, the limit of the quantity 3x plus 4 cubed as x approaches 1. Distributing the limit notation inside the parenthesis and applying the constant multiple theorem on the first term, it will become the quantity 3 times the limit of x as x approaches 1 plus the limit of 4 as x approaches 1 cubed. Applying the intended limit laws for each term, it will result to quantity 3 times 1 plus 4 cubed. Simplifying the given, it will become 7 cubed, which is equivalent to 343. Thus, the limit of the quantity 3x plus 4 cubed as x approaches 1 is 343. Lastly, the radical or root theorem. It states that if n is a positive integer, the limit of the nth root of a function is just the nth root of the limit of the function, provided the nth root of the limit is a real number. Thus, it is important to keep in mind that if n is an even number, the limit of the function must be positive. Example, the limit of the cube root of x squared plus 4 as x approaches 2. Distributing the limit notation to the terms inside the radical, it will become cube root of the quantity of the limit of x as x approaches 2 squared plus the limit of 4 as x approaches 2. Applying the intended limit laws for each term, it will become cube root of 2 squared plus 4. Simplifying the given, it will become cube root of 8, which is equivalent to 2. Thus, the limit of the cube root of x squared plus 4 as x approaches 2 is 2. Those are the 8 limit laws. As a recap, we have the limit of a constant is itself, substitution law, constant multiple theorem, addition theorem, multiplication theorem, division theorem, power theorem, and radical or root theorem. At this point, let us discuss the application of limits in real life. Limits have numerous real-life applications. In chemistry, as an example, we could have a chemical reaction in a beaker starting with two chemicals that form a new compound over time. The amount of the new compound is the limit of a function as time approaches infinity. Similarly, if you drop an ice cube in a glass of warm water and measure the temperature with time, the temperature eventually approaches the room temperature where the glass is stored. Measuring the temperature is the limit again as time approaches infinity. In engineering, in making calculations, engineers will approximate a function using small differences in a function and then try and calculate the derivative of the function by having a smaller and smaller spacing in the function's sample intervals. For example, when designing the engine of a new car, an engineer may model the gasoline through the car's engine with small intervals called a mesh. Since the geometry of the engine is too complicated to get exactly with simple functions such as polynomials, these approximations always use limits. Now, to test your understanding on the topics we have discussed, you will answer a series of activities. You may answer orally, comment your answer on the comment section, or write your answers on a sheet of paper. Remember, you need to observe the proper way on how to write limits for each part. You are given 5 seconds to answer for the first and second part, and 10 seconds for the last part. Are you ready? Let us begin. For the first part, determine the limits of the following functions based on its given table of values. Number 1. Based on the given table of values, what is the limit of x squared minus 2x plus 4 as x approaches 1? Number 2. Based on the given table of values, what is the limit of x minus 1 all over x plus 1 as x approaches 0? For the second part, consider the function f of x whose graph is shown on your screen. Determine the limits of each function based on the given graph. First, what is the limit of f of x as x approaches negative 2? Second, what is the limit of f of x as x approaches 0? Third, what is the limit of f of x as x approaches 3? And for the last part, evaluate the following using the limit laws. First, the limit of 3x squared minus 4x plus 5 as x approaches 2. Second, the limit of 2x all over 8x minus 5 as x approaches 3. Let us now check your work. The answers are as follows. Did you get them all correctly? Good job, FerNanDino teens! Did you learn something from our lesson today? That's great! These are the references used in this video lesson. Again, this is Sir Harley, ending this learning episode with the lesson to ponder on. In life, be like Dino. No matter how hard the trail is, do not give up if you want to approach the finish line. Simply, this means that success is only for those who choose to overcome the limit and finish the race. As you ponder on that, let me thank you for tuning in to FerNanDino Teens TV. Stay safe and God bless.
Uy, Dino, saan ka nagpunta? Yan tuloy na mismo ang naging talakayan ni Sir Harley. Alam mo ba, meron palang 3 paraan para makuha ang limit ng isang function. Looking at a table of values, looking at the graph, at evaluating true limit laws.
Oo nga, Dino. Ako rin maraming natutuhan. Nalaman ko sa talakayan na mayroon 8 limit theorems. Ito ay ang mga limit of a constant is itself, substitution law, constant multiple theorem, addition theorem, multiplication theorem, division theorem, power theorem, at radical or root theorem.
Wow naman, Fer at Nan. Ang galing, nakanig talaga kayo. Kayo, FerNanDino Teens, marami rin ba kayong natutuhan? Kaya naman,
Maraming salamat, sir.
Isa na namang makabuluhang talakayan ng ating natunghayan FerNanDino Teens.
magkita-kita tayong muli sa pagtuklas ng bagong kaalaman dito lang sa
FerNanDino
Cheers!
TV,
na kung saan ang kabataang FerNanDino ay angat sa angking talino.
Bagong umaga, yakapin mo ang bagong pag-asa. Simulan mong abutin ang iyong pangarap na magbibigay dangal sa iyong bukas. Ang suliranin, hindi laging nandyan, dapat mong harapin. Kami iyong kasama sa bawat takin, magkaakbay nating lulutasin. Dito sa FerNanDino Teens TV, ang boses ko ay mahalaga. Dito sa FerNanDino Teens TV, ikaw lagi ang bida. Ang mga aral ay ginintuang atin ng bawat guro na siyang gagabay sa iyong pagkamulat. Naway umukit ito sa iyong isipan, maging mapanuri, sundin ng wasto.